Welcome to the TopView and Mqtt overview video. Starting with TopView version 632, TopView can act as both a publisher and subscriber for Mqtt messages. In this video, we'll give a brief overview of Mqtt and also explain the support for Mqtt within our TopView alarm and notification software product. Although Mqtt has been around since the late 1990s, it's gained recent popularity with Internet of Things applications. Mqtt is a publish-subscribe protocol that works extremely well for collecting data from remote sensors that may have intermittent network connections, require a low bandwidth communication protocol, and may run on a wide range of lower-end devices. For SCADA and automation users, Mqtt is commonly used to collect data from remote sensors. In addition, it can be used to send commands to remote devices and also to publish automation data to other automation systems and devices. Let's start by looking at how sensor data has traditionally been collected through polling. A data server is configured with the sensors that it must monitor. This configuration may be created beforehand or by the connecting clients who instruct the data server of the sensors of interest. The data server connects to the sensors using an agreed-upon protocol and will normally poll the sensors to maintain the current values and statuses. Clients who connect to the server can request the current values and statuses of sensors. The protocol between the clients and the data server is typically different than the protocol between the data servers and the sensors. Sensor values read by the clients can only be of a type supported by the protocol between the clients and the data server, therefore limiting the types of sensor data that can be supported. With Mqtt, the data server is replaced by a broker. The broker may exist in the local network or in the cloud. Unlike the data server in a polling configuration, the broker is not configured with the desired sensor data. The broker is a conduit who passes messages between the sensors, the publishers of data, and clients, the subscribers of data. Also, unlike the data server, the Mqtt broker does not make connections to the sensors. Both publishers and subscribers connect to the broker. On the publishing side, sensors and other providers of data send messages that contain a topic and payload. The topic usually describes what the data is, for example, a sensor ID, and the payload contains the message content, for example, the current sensor measurement and status. Clients subscribe to desired topics and receive messages from the broker when messages with matching topics arrive. If the broker receives a message for which there are no subscribers, the message is usually discarded. Mqtt is based on TCP/IP and allows various connection options for the publishers and subscribers from purely open, unsecured connections to encrypted and secure connections. Let's look at the message details, the Mqtt topic and payload. The topic is a string that contains multiple levels separated by a // and typically contains information that identifies the sender of the message and what the message contains. For sensor data, the topic may include a sensor ID, the name of the sensor's owner, or the location of the sensor. Since clients subscribe to topics, clients must be aware of the format and details of the topics for the messages they would like to receive. The payload is the message content, usually containing the data values and statuses. Unlike the polling example we discussed, there are no rules for the format of the payload. The payload is commonly a string and often contains data formatted as JSON or XML, but there are no rules. The publisher and subscriber must agree on the format of the payload, but the content can be anything. Although Mqtt examples often describe sensors and measurement data, you can use Mqtt to send image files from a security camera or for transferring files between two machines. Here are 3 examples of how we can send thermostat data using Mqtt. In this example, a thermostat can send 2 pieces of data, the thermostat set point and the current temperature reading. In the first example, the current temperature value is the only data in the message payload. Since the thermostat can send both set point and temperature data, the word temperature is included in the topic. The second and third examples send the set point and current temperature in one message and therefore one payload. The first one formats the data as JSON and the second as XML. In addition to the set point and temperature values, the payload also includes the time at which the values were sent. In the JSON and XML examples, the subscriber must parse the values and timestamps from the message payload. TopView supports Mqtt as both a publisher of and subscriber to Mqtt messages. As a publisher, TopView takes on the role of the sensor devices that we discussed in earlier examples. Publishing is supported by all versions of TopView. As a subscriber, our product TopView for Mqtt allows TopView to monitor and parse Mqtt messages as the data source for TopView alarm and notification functions. All versions of TopView can publish Mqtt messages. There are 4 TopView events that can trigger the publishing of messages. The first 3, the alarm, acknowledge, and return to normal events, will publish Mqtt messages when these events occur to alarms in the TopView engine. This allows users to publish changes in alarm state or to send Mqtt notification messages upon TopView alarms. The refresh event will trigger Mqtt messages during each refresh interval of the TopView engine and can be used to publish TopView monitored values and statuses as these items change in TopView. When publishing Mqtt messages from TopView, users have full control over the topics and message payload and can embed dynamic information into the topic or payload using any of TopView's extensive list of placeholders. Our product TopView for Mqtt uses Mqtt messages as a TopView data source. Mqtt event and value messages from one or more brokers can be monitored and parsed by the real-time TopView engine to perform TopView's alarm and notification functions. To make it easier for TopView users to get started with Mqtt, TopView installs a local broker that can be used for testing, publishing, and subscribing. The broker includes an optional simulator for testing subscribers like TopView for Mqtt, where TopView uses Mqtt messages as a data source for alarms and notification. When publishing to the broker, received messages are displayed on the broker's screen. Subscribers can monitor both the simulator messages and other messages published to the broker. The TopView broker is also used in our other Mqtt videos when we demonstrate publishing and subscribing with TopView. Thanks for watching our TopView and Mqtt overview video. Please take a look at our other TopView Mqtt videos for detailed examples of publishing and subscribing with TopView. TopView can be downloaded for free, and we invite you to try it out. TopView contains many features beyond Mqtt publishing and subscribing, and we hope that you will investigate those features once you start using TopView. Please contact us with any questions you have about this video, about TopView, or any other Excel products.